Hello, I'm Victoria Wang, and today we are going to be working on differentiating by using the chain rule. So, basically, what the chain rule says is that if the quantity of an equation y depends on the quantity of an equation u, and equation u depends on x, then the derivative of y in respect to u times the derivative of u in respect to x multiplied together would equal the derivative of y in respect to x. Okay, so we will demonstrate this in the following equation, which is h of u tangent cubed of square root of u squared minus 1. Okay, so here we have a complex trigonometric equation to differentiate. And we see that we not only have the trigonometric equation, but we also have a radical. And additionally, we have inside of the radical a quadratic equation. Okay, so in this case, that we have so many different equations within this equation, we must use the chain rule. And what we do is that we tackle each one of these expressions separately, and we differentiate them. At the end, we multiply each one of the expressions derivatives. Okay. So some people usually take the radical, like this part, and they substitute the whole thing for a single variable. And I believe that's just for cleaner sheet, and so you can get a closer look at the trigonometric equation. But I enjoy differentiating directly, so I don't use the substitution. So that's what we're going to be doing. Okay, so we start off here. You see that the tangent is elevated to the third power. So here we use the power rule. Same thing as always. Multiply power and subtract 1. So you have 3 tangent squared of square root of u squared minus 1. Right? So that's our first step. Then we get the power rule. And then you see we have then the trigonometric equation. So we will go on and multiply the derivative of the trigonometric equation. So the derivative of tangent is secant squared. So we get secant squared of the square root of u squared minus 1. Okay. So here you have, we've already tackled the power rule, trigonometric, and now we follow up with the radical. So you get that you may switch the u squared minus 1, just elevate it to half, and you just multiply. The derivative of this would be 1 over 2 times the square root of u squared minus 1. Okay? And then lastly, we tackle the quadratic equation, which is u squared minus 1, and the derivative of that would just simply be 2u. So now what we have left, we multiply it and simplify. So I'm just going to multiply everything together first. So you have 6u times tangent squared square root of u squared minus 1 times secant squared of the square root of u squared minus 1, and this would just all over 2 times square root of u squared minus 1. Okay, so now what we have left, we simplify 6 and 2, which would give us our final answer. That would be 3u times tangent squared, the square root of u squared minus 1 times secant squared of the square root of u squared minus 1, all over our square root of u squared minus 1. And that would be our final answer. Thank you.